Hi, hello everyone. Welcome to this webinar. Today we are going to discuss data visualization for decision making. So, data visualization is nothing but pictorial representation of data. When we have huge data, it is nearly impossible if we have to go through each and every record of data and then try to draw some meaningful inferences from it. Instead, if we present it in a graphical format, if we visualize it, if we create different types of charts and plots with that data, it becomes much easier for us to communicate the point, to analyze the data, and it becomes much easier for the end users also to understand what is going on with their business. The stakeholders can clearly understand the performance of the business. So, creating impactful visuals is the key for anybody who's working in the field of data analytics or data science in business intelligence. Okay, maybe I should put it that way. Whoever is a part of BI, you would know that data visualization is an integral part of BI. It is an inseparable part of business intelligence. Because ultimately, all the analysis that you do on your data finally leads to how are you going to present it. No matter how good you are at analyzing your data, if you don't know the right way to present it to your client, if you are confused about which chart do I create for a given requirement, which chart to create when, how do I present this analysis in a graphical format, what will be more impactful? Because there could be n number of ways of presenting the data, but presenting it in such a way that it makes the life of the end user easy, right? It should not be, again, it should not add cognitive load on your mind as to, they should not keep spending more time trying to understand the charts that we have created. The charts should be impactful, they should be self-explanatory. Simplicity is the key, I would say. So we will be talking about some data visualization, best practices and principles, and we will see how we implement them by creating some charts in Tableau. And of course, we will have a discussion on which chart to create when. Which visual is the best for a given requirement, for a given scenario, or for a given business. So, with this agenda in our mind, let's go ahead and start talking about these things. So, first and the foremost thing would be understanding what is data visualization, why do we need it? Now, data visualization is nothing but pictorial representation of data. Right. Imagine if you are given not even big data. Okay, let's just take small data. Maybe you're given about 1,000 records of data. Okay, or forget 1,000. Maybe you're given about 100 records of data. Okay, if you have to go through all those 100 records of data, and if you have to understand the performance of the business, you have to figure out the trends, the patterns, the anomalies, the outliers, it becomes nearly an impossible task. If I have to go through each and every column's data here from every record and figure out what's going on in the business, most of the things will go unnoticed. I might not be able to recognize the patterns. I might not be able to recognize the trends, seasonality. So instead of looking at the data like this, if we could present the same data in a graphical format, it will add a lot of meaning and it makes it very easy for us to understand and analyze the data. Okay, so what is data visualization? Pictorial representation of data, right? Why should we do this? Because a picture speaks 1,000 words. In simplest form, I can say picture speaks 1,000 words. Here, imagine, suppose I use the term water cycle. Right? Whether or not you're able to recollect every stage in that process. I'm sure you all have the image of a pond or a river, arrow marks going up representing evaporation, clouds, and then rainfall coming down. Right? Even if you can't name every stage, I'm sure you have this image in your mind. So that is the power of data visualization. Picture speaks 1,000 words, and when we see images, they tend to stay with us for a longer duration of time. Okay. Next thing is, or another example, I would say, suppose periodic table. All of us back in school, in chemistry, we have learned the periodic table, the elements in the periodic table, their atomic numbers, their atomic weight, their valency, the way they were grouped. Imagine if that was given to you as a list of elements in a tabular format, one after the other, and you have to by heart the everything about it, the group that it belongs to, and all that. It would be so difficult. Instead, how is the periodic table presented to us? In a graphical format, in a pictorial format, elements are nicely grouped, color coded. They are color coded, and it makes it easier for us to recollect things. At least I'm sure all of you have the image of a periodic table, whether or not you remember every element in it, isn't it? So that is the power of data visualization. And in BI, how is it used? It will help us provide the right information to the right people at the right time so that they can take the right decisions. That is the purpose of business intelligence. And we are going to use visualization to achieve this purpose. So when we are creating visualizations, we need to bear a few principles in mind. So we'll try to understand each of those principles using some small examples here. For example, the first picture. Which of the smaller rectangles is the lightest? The smaller ones. Which one appears to be the lightest? Now, most of us might feel that this is the lightest, but actually all of them are of the same color intensity. Then why is this perception varying? Why is our perception varying? Why do I feel this is lighter and this is brighter? Because of the background. It is kind of creating an impression as if this one is lighter and this one is dark or bright, given all of them are of the same color intensity. So what is the takeaway from here? We do not perceive absolutes, instead we perceive differences. So our mind is tuned to constantly trying to pick up or look for differences, not similarities. Okay, differences. Something looks different compared to the other one. So that's how the human mind is trained. So this is one principle we need to keep in mind. Now look at this. Which box or which block there appears darker, A or B? Right? Obviously, A might look darker to us here, but actually both of them are of the same shading. Then why did I feel that A was darker and B was lighter? Familiarity. We are all familiar with this pattern, isn't it? Right from our childhood, we have seen this pattern. Where did you see this pattern? Chessboard, right? The chessboard. So, very, very important point comes here that don't try to go against the familiar patterns. There are people would be familiar with certain patterns in their life. And when we are presenting the data, we will follow that pattern. We will not go against that pattern and present something else because that will again increase the cognitive load on the human mind. Okay. We observe a lot of information through our eyes and lot of patterns are already pre-feeded in our memory because we've been seeing them regularly all through our life. So when you're creating visualizations, another important point to remember is follow the patterns. There is no harm. Don't try to do something completely, don't go completely out of the box. And just because you have to think out of the box, don't create anything weird that goes against the general perception of the people. Okay, so for example, if you take any project, there are different stages. Like usually, if the project is going smoothly, if it is running smoothly, and we are expected to give a bug-free delivery and on-schedule delivery and all, it is indicated with a green sign. If at all there are some hurdles in the project, maybe there is a chance of not being able to deliver it on time. Maybe there's a chance of schedule deviation, or maybe there are some unexpected bugs getting into the project. Maybe orange indicate because again this is a general perception right from our childhood. We are taught that green means go. Traffic signals. When you see a green light, you can go. You know that you have to move, isn't it? Means it's good. It's good. Orange means you're waiting. Red means you have to stop. Something is wrong there. You have to stop. So if we violate this pattern and if we indicate something good in red color and something bad in green color, it goes against the general perception of the people, isn't it? We should not do such things. So always okay, sorry. I think there was a small glitch there, but I hope you're able to see my screen now. Okay, this is what we were talking about, familiar patterns and all. Now, when you go here, okay, when you go here, there's this flower, and when I show what is present inside that flower, once I reveal the dolphin shape that is there in the flower, now you will not be able to unsee it anymore. Even after 10 seconds, if I remove this or tomorrow I show you this flower, your eyes will be drawn towards the dolphin shape that is embedded inside that flower. Why? You can't unsee things once we have seen. So when you're presenting the reports to your client, be very careful. Do a double check, triple check if necessary, because once you have sent the report to them, once you send it, once they've seen it, there is no unseeing it. Okay, because again, our memories are quite strong. So we do not perceive absolutes. Instead, we perceive differences and contrasts. Our eyes are drawn to familiar patterns. And when you show something, make sure that you are presenting the correct information, because you may not have the chance to go back and say, I made a mistake here, let me fix it for you. Okay, people will not appreciate it as much. Your client will not appreciate it. Next thing is the memory. Working memory of human beings is is a little poor, we could say. Not I mean, this is in comparison to a machine. Okay, obviously we are humans. So when you're presenting something, for example, there is this slide here. I'll keep it there for a few seconds for you to see and observe, and let me just take it away and put it back. Okay, do you see any difference between the previous slide and this one? There is a difference. Okay, where is the difference? Let me put the slides side by side for you to observe. The difference is in the background. If you notice closely, we have some bushes here and here we do not have them. But most often, if I'm asked to spot the differences, I think my eyes will be drawn to the foreground. I am probably going to focus on the sphinx, on the people standing there, their shadows, their posture. Then I will think about the background. So when you're creating a dashboard, when you're creating a report, put the most important things in the foreground. It's very important that you put the most important things in the foreground. Some sort of supporting information, if any, could be sent to the background. Okay. Because again, we can't attend to each and everything that we see. Working memory is limited. We can't attend to each and every point that we see. So we might want to keep the most important things in the foreground or at the. Look at this visual, right? What can we say about this chart? Is it a good visual or is it a bad visual, right? So if I am asked this question, I would say it is a good visual, because what is the purpose of data visualization? The purpose of data visualization is to at a glance, give some high level understanding about the data. At a glance, help people try to pick up at least bare minimum things about that chart that you're representing. So the moment I look at it, without much thought, I know that it is talking about injuries. How do I know that it is talking about injuries? Because I can see the title on the top left corner, bumps, bruises, and breaks. Okay. So what you see the top left corner is very, very important and precious space because that is how we are made to read and write all through our childhood and life, right? We go from left to right and we go from top to bottom most often, right? Especially English language. You write like this from left to right and then you go from top to bottom. So this top left corner space is very important. Without our own knowledge, our eyes are drawn towards this space the moment we see any image or report. So one glance at it, I know it's talking about injuries. And when I look at the posture and the attire of that person in the image, I know that it is talking about injuries that players have suffered, not regular people, but players. Players during the game season, during NFL. Okay. And I know that most of the injuries have occurred on the knee, followed by that we have ankle, and then upper leg, and so on, shoulder, head. And look at this. This is a static image, okay? But in real time, apart from just giving a high level presentation of what's going on, we should also allow the users to do a deep dive into the data wherever necessary. So if I hover the mouse pointer here on this mark corresponding to head, I can see 87 of these 96 injuries are due to concussion. 7 of them are jaw and 2 other. Right? So we're not just presenting a high level data. Wherever required, we are allowing the people to do a deep dive and also get further information about the chart, about the point of interest. So this should be the purpose of data visualization. Give a high level understanding, also give them the option to a deep dive, to do a deep dive wherever necessary, whenever necessary. So this is about the concept of data visualization, the purpose of data visualization, why do we need it and how does it help us? Okay, so I will now take you to Tableau and I will show you some charts. We will also discuss what is the right visualization type for a given requirement. And then we will create some visuals. I'll show you the hands-on one. I'm going to open Tableau that I have installed on my system. And I will use an inbuilt data source present here. Okay, this is a retail business, and the data corresponds to a retail business called as Superstore, where different types of products are sold. Okay, it's like Amazon or like Flipkart. There are many elements that are products or items that are sold here, and we're going to use this data. I'll create a very basic text table first. Okay. Now, when there are so many ways in which we can present the data, here itself there are about 24 graphs. You can create bar graphs, you can create pie chart, you can create heat map. There are many ways. You can create geographical maps, line charts, area charts, histograms, box plots, bubble charts, dual axis charts, dual combo charts, Gantt charts, so many. So when there are so many ways in which we can graphically present our data, when do you think we should still go and create a normal table? Isn't it? So text tables are the most powerful data visualization type. It is the most powerful data visualization type. Why? Because it is used extensively in financial domain, wherever money is involved, not necessarily only financial domain, but wherever money is involved. What are text tables? When do we create them? It is just a two-dimensional structure. You organize data into rows and columns, and we create it when we have an eye for detail, when attention to detail is more important, right? Rather than a quick comparison. When attention to detail is important, when you have to show the exact value rather than a quick comparison. So our bank statements are nothing but text tables. How much, what we would like to know each and every transaction made, whether the amount is debited, whether the amount is credited, What is the total amount debited? What is the total amount credited? What is the overall balance? Isn't it? You would want to know right down to the last penny. So it's a good example of text table. The not just a good example of text table, good example of why we should create text tables and when we should create them. Profit and loss statements of companies, organizations, balance sheets, okay, quarterly reports that are submitted by companies showing their progress. Or for that matter, let's say you went out for shopping and you purchased a few items, the receipt that you get, the invoices that you receive, the bills that you pay, the checks that you receive, they're all nothing but text tables. Okay. So, how do we create a text table here? Very quickly now. Let's say across different years for various products, which we will call as subcategory here. Let's say I need to show the sales. Okay. So what should be organized as columns and what should be organized as rows is your choice. You can decide what should be arranged as rows and what should be arranged as columns simply by taking the fields to the columns and to the rows shelves here. This is called as a shelf. In Tableau, we call these as shelves. Okay. So you take fields into rows, you take fields into columns to make sure that you organize data. So you decide the structure of the chart by simply taking fields into rows and columns. It's a little slow. So I'm taking order date to columns and I will take subcategory to the rows, that is different products. And I would like to look at the sales. I'll directly drop it into the table. Directly drop it into the table. Okay, so I can see what is the value. Each and every value we can see. Now, will you leave it like this? If you are supposed to create a chart, would you leave it like this? Definitely not. Can't just leave it like that. It may not look very good or presentable. Like, what can I do? We are talking about sales, and this is US data. So, first thing to convert this into a better visualization, of course, all of us would create this, but to convert this into a better or a presentable visualization, I might want to format it. Maybe the number, the numeric representation of that number, right? I would want to put a dollar symbol because this is United States data. Maybe not show so many decimals. Okay, so you can decide whether you would like to keep 1,000 separators or not. Better to keep them. Better to keep them. It becomes easier for people to read the number. Okay. And of course, we can play around with the colors and all that. You can use different shades and all that. So bare minimum, the formatting of the number should be accurate. This is the bare minimum that we can do for any chart. And you might want to add totals. Because definitely people would want to see the total. What is the column grand total? What is the row grand total? So apart from showing the individual numbers, we're also showing what is the total of that particular product. How much did I sell? How much of accessories were sold? How much of appliances were sold? What was the sales that happened in 2014, in 2015, 16, and 17? And what is the overall grand total? Okay, now this chart looks complete. Now, beyond this, if you might want to add some sort of color to highlight the totals and all that, it's up to you. Okay, now when we talk about colors, use nice subtle colors. Don't go with very bright colors, which might not look so good. Okay, don't use colors that can, cause discomfort on the eye. For example, here I have a grand total. Imagine if I used something like this, it obviously doesn't look good. It doesn't look good, right? So maybe a lighter shade or some soothing color. Okay, not very bright. This is also not very good, but I hope you're getting the point. Maybe something like this. Maybe something like this. Just to highlight that part. Just to highlight that we are showing the grand totals over here. This is more than enough. More than enough. So be very careful with colors. Use light colors. Don't use very bright colors that can come out very hard on the eye. Pleasant colors. Okay. So this was about how to create a text table, a simple text table. Now there are different charts that go under the umbrella of comparative analysis. And comparison is very important. Like this is a very common requirement. In any project, there could be multiple requirements on comparison, relative comparison. Relative comparison, meaning what? Let us say a business is operating across multiple regions. We would like to know which region is performing better than which other region, right? Let's say I'm selling about 10 or 20 products. I would like to know sales of which product is better and sales of which of the products are not so good. So there could be multiple requirements on relative or categorical comparison. Okay, so let's say for various subcategories, I would like to see the profit. Now, if the requirement is to show the profit from different subcategories, we could leave it here. My job is done. I'm showing you the list of subcategories. I'm showing you the profit. These members, these are losses, right? We have the axis oriented around zero. From zero, we have positive values in one direction. I have negative values in another direction. I could stop it here, but that wouldn't be good. So what are the bare minimum things that we should be doing on this visual, on this graph, to make it more presentable, to make it easier to understand, so that people can comprehend and understand very easily what's going on? The first second thing is maybe utilize the space that is on the canvas. Why not use the whole space? Why leave blank space over here? The next thing is maybe provide the labels, right? Provide the labels indicating the values. So we could make use of labels there. Next thing is, of course, because this is currency again, you might want to format it. Depending on what is the currency, you might want to format it. How would you like to show negative values? Maybe I just want to indicate negative with the negative sign before the dollar symbol. Or maybe I just want to indicate negative by putting it in brackets. That is also one way of indicating negative values. Okay, depending on how your client would like it. Furthermore, what else? Maybe the ones that are profitable, I'll show in green color, and the ones that are into losses, I might want to show it in red color. These are all additional things that we are doing, right? So a simple if statement. Then I will mark it as profit, else I will mark it as loss. Now I'm going to bring this into color shell. Now, when we use something in the color shell, Tableau uses blue and orange as the default color schema. Once upon a time, it was green and red, green for profitable and red for unprofitable. But now it is orange and blue because even people who might have some visual impairments, who can't distinguish colors, they can clearly say the difference between, tell the difference, notice the difference between orange and blue compared to green and red. So that is the extent to which the data visualization tools are fine-tuned these days. However, if you want to go, if you would like to change it, you can definitely do it. Let's say we'll indicate loss with green and profit with red. Okay. So we have different color palettes. A lot of color palettes are there from where we can choose the color. So, sorry, made a mistake. Profit we'll indicate in green. Profit we will indicate in green. Maybe I'll take this shade. And loss, I will indicate in red shade. Okay, so profitable ones and loss-making ones. So like this, you can present it beautifully. See, if the requirement was to show the profit across different products or subcategories, I could have stopped it here. I could have stopped it here saying, here, these are the list of items and this is the profit. But what did we do? What did I do? I didn't stop here. I used the data visualization best practices to convert it into this visual. And I'm sure you would appreciate this better than the previous one because it's communicating the point more clearly. Okay. So there are many charts that we could create for comparison. These are horizontal bars. We could have vertical columns. We could have just dots indicating the value, dot plot. We could have a circle plot. Many things are there, but the best way to represent this data is to create a horizontal bar graph. For comparison, the best chart is any given time horizontal bar graph or vertical column. Now, how do you decide whether horizontal bar is better or a vertical column is better? Is this looking good or is the other one looking good? So there is a simple rule here. If the number of items are many, if you have many items, go with horizontal bars. If you have more than 10 items, go with horizontal bar. If you have less than 10 items, go with vertical columns. Okay? The rule of thumb is if you have more than 10 items in the member, 10 members in the field, go with horizontal bars. When you have a tall data, go with horizontal bars. Then you have lesser number of members in a field, you can go with vertical columns. Okay. Now I'll show you something that we use for composition analysis, or charts that are used to indicate the shares or to indicate the proportions, to indicate the ratios, or not exactly ratios, something like that, or to perform part to whole analysis. There are again many charts under this umbrella, the best being pie chart. I know it's a very controversial chart, okay? Pie chart, if I go and say this is the best chart, many people will disagree with me. But there are some rules that we should follow when we create a pie. Imagine this is 100% of the value. And it's coming from different parts, let's say central region, east region, south region, west region, by selling different items. So what is the share of each member is what we are going to indicate. Now, when should we create a pie chart? Because it's a very controversial chart. Okay. If the number of slices are less, maximum up to 8 slices. Don't go beyond that. If you have more than 8 members, don't create a pie chart. There will be too many slices and it will look cluttered. In that case, any given day, a better alternative to a pie chart would be bar graph. It would be a bar graph. But when you have lesser number of slices, 8 or less than 8, at least 2, of course, or maximum up to 8. Minimum 2, maximum 8 slices, you can create a pie chart. So let's say for different regions, I would like to show the profit from various regions. Okay, now creating a pie is fine because I have data for just 4 regions. So I'll just create a pie chart and utilize the space. Give it the label. Labels are bare minimum again. You should always provide the label for every chart, indicating the values. This is perfect. Okay, but imagine a scenario where you have too many slices. For example, let's say I want a pie representing the profit from different states. Now I have data for 49 states over here. You will also agree when you see this chart that it is not that easily readable, at least not as easy as this graph. Definitely not as easy as this graph. There are 49 slices, and depending on the value, higher values with larger slices, lower value with smaller slices is what we think, isn't it? Now, some of the slices here are so thin that we don't even know that they exist. Georgia, Idaho, here you see there's Kansas. We can't even see it. It is so insignificant. So what are the rules? First of all, the number of slices should be less, maximum up to 8. So I violated that rule. Here I have 49 slices. And then each slice should be large enough for the human eye to see and understand that it exists over there. Look at this for me. Right? It's so difficult to see these slices. It's taking quite some effort from my side to pinpoint to that slice, to pinpoint to that slice. Okay. So if the slices are so thin that it's visually difficult to even figure out that they are there, they exist, then don't create a pie chart. Another point to remember is, now suppose you look at this blue slice for Georgia and look at this gray slice, which is Pennsylvania, or this, purple, or this gray slice for Ohio. Georgia, 16,250. It is a profit. And what about Ohio? 16,971, but it is a loss. And look at the size of these slices. Both of them are of the same size. Now, how would I know by looking at the slice which one is positive and which one is negative? Which one is indicating a profit and which one is indicating a loss, right? So this is another drawback of a pie chart. That is the reason why they're considered to be the most controversial charts out there. So when you have both positive and negative values, never create a pie. Okay, so what are the scenarios where you should not create a pie? When the slices are more than 8. When some of the slices are so thin that it is very difficult to even recognize their presence. And when you have negative values also along with positive. So this is an example of when you should not create a pie. And this is an example of when you should create a pie. A few other things that you might want to bear in mind is pie always starts at the 12 o'clock mark. The first slice always starts at the 12 o'clock mark. Okay, on the clock we have 12 here, right? So it should start there. And then preferably it should be sorted. You start off with the largest slice, largest, and then the second largest, then the third largest, so on. You go up to the smallest. So on, we go up to the smallest. Here, that is not happening automatically. Some tools do it automatically. Some data visualization tools do it. Some of them may not do it. Like Tableau here is not doing it. Of course, it is starting the slice at the 12 o'clock mark, but I don't necessarily see the largest slice here. I should ideally be having west, followed by that east, and then south, and last slice should have been central. So again, sorting of the data has to happen. Sorting of the data has to happen, and this is something people generally ignore. Don't ignore this rule, it's important. What is the thumb rule for creating a pie? Pie should start at the 12 o'clock mark, which will be taken care of, but make sure that it is also sorted, starting with the highest member all the way up to the smallest member or the least valued member. Okay, so these are some best practices to follow when you're creating a pie chart and scenarios where you should avoid creating a pie. All right, so I'm not seeing any questions. If any of you have any questions, you can put it there and I'll answer. So proceeding further, after tables, after comparative analysis and composition analysis, we will now go to trend analysis or time series data analysis. And what would be the best way to present time series data? When I say trend analysis, we're basically checking the trend in the data over a period of time. What is the trend in the data over a period of time? So you need time series data, data gathered for over a period of time. So overall, over a period of time, is there an upward trend? Is there a constant trend? Or is there a downward trend? Slowly you see graph going down like this. Obviously, there's a downward trend. So I will use date, and then you can choose the level at which you want to present it. Let's say we are checking at the sales. So now look at this graph. What do you think is the trend in the data over a period of time? Though initially it might have dropped, after that steadily it is rising. So there is an upward trend in the data. Right? There is an upward trend in this data. Then what about the seasonality? What is seasonality? The periodic rise and fall in the data or some sort of a pattern that repeats itself at regular intervals of time. For example, take sales of ice creams. It would increase in summer, decrease in winter. Again, increase in summer, decrease in winter. That is a seasonal trend, seasonal trend. Okay, some pattern that is happening. Now, here is there a seasonality? If you observe closely, yes. Consistently, quarter one is the is the one with the least sales, and quarter four is the one with the highest sales. Again, quarter one, least sales, quarter four, highest sales. Quarter one, least sales, quarter four, highest sales. Quarter one, least sales, quarter four, highest. So there is a pattern here. There is a seasonal pattern. So all these things, the trend and the seasonality, they all emerge when we create line charts for analyzing time series data. Suppose the requirement is to find the correlation between two variables for correlation analysis. What is correlation? Relationship between any two given variables. Relationship between any two given variables. For example, let's say I have to check the relation between discount and the profit made by a business. Let us say if I'm offering 10% discount, the profits are high. Same item, if I'm going to sell at 20% discount, obviously I'm compromising on the profit. At 30%, it further goes down. 40%, it further goes down. At some point, I might even be ending up making a loss. So what is the relationship between discount and profit? There is a downward relationship. There is a negative correlation. Negative correlation. Why? Because as the value of discount increases, the value of profit is steadily decreasing. Increasing one value is leading to decline of another value. They are inversely proportional. They are inversely proportional to each other. So there is a negative correlation between them. Okay. If someone says, okay, now what is the relationship between calories consumed and the weight gain of a person, right? So if I'm consuming lesser calories, maybe only 500 calories per day, weight gain will be less. 1,000 calories, I would be putting on more weight. 2,000 calories, much more. So as the calories consumed keep increasing, the weight gain of a person will increase, isn't it? Or as the sales of an item increases, the profit might increase. So when increasing one value leads to increasing of another value, then we say there is a positive correlation. There is a direct proportion. Okay, now why should we understand about correlation? Because that is the first step towards performing prediction. Suppose someone asks me, predict the power generated in this power plant, I will let you know the wind speed. First of all, I need to check whether there is a correlation between the power generation and wind speed in that power plant. If there is a correlation, then I can do the prediction, right? So the best chart for correlation analysis is a scatter plot. It talks about correlation analysis. If you, in the question given to you, okay, let's say your client has given you a set of requirements, and in the requirement given to you, if the client uses words like proportionality, what is the proportionality? What is the correlation? Can you perform prediction analysis on this data? Then first you have to create a scatter plot. That's how you decide. So I want to check the correlation between power generation and wind speed across different windmills. So now look at the data. By looking at this data, what do you think is the correlation? Obviously, there seems to be a positive correlation. As the wind speed increases, the power generated will increase. So there is a positive correlation. Now, if someone tells me that the wind speed is going to be 15 meters per second, what will be the power generated? I will look at this data and I will tell them approximately 27 or 28 megawatts of power generation will happen. Right? So there is a correlation. They are related to each other. That is why we can perform prediction. If there is no such correlation, then we cannot perform prediction. Okay. Then another umbrella under data visualization would be Distribution analysis. There are many charts under distribution analysis. You can create histograms. You can create box plots. You can create violin charts. You can create pair plots. Okay, there are many charts again under distribution of data, distribution analysis. Now, what is distribution analysis, first of all? Histograms as are the most popular here. You can, of course, create other charts also. What is the most distribution in the sense, rather than looking at the overall picture, we will break the data into smaller intervals. Okay, rather than looking at the overall picture, overall performance, we will break the data into smaller intervals to understand the business better. After breaking it into smaller intervals, we might get more insights about the data. Okay. So, for example, let's say I'm planning to I'm planning to take a competitive exam. Okay, and let's say I've shortlisted two training institutes, A and B, who provide the necessary training or coaching for these exams. Now, A and B both seem to be the same to me. Both seem to be at par with each other. Like both of them are charging the same fee, let's say. Let's say both of them are covering the same syllabus. Both of them are very near to my house. So I'm not able to come up with that differentiating factor to decide where to go and invest my money and time. So now let's say I asked Dave, what is the overall range of scores that people obtain? People whom you train, what is the range of scores they obtain? Let's say A said 600 to 700. Okay, now when I go to B and ask the same question, what is the overall range of scores that your people obtain? Let's say B also said 600 to 700. Now I'm confused. Where should I go and join? Where should I put my money? And more importantly, where should I put my time? Right? Because I need to learn all these things. So rather than looking at the overall picture, imagine breaking it into smaller intervals. Imagine breaking this into smaller intervals, which are called as bins. And let's say I'm going to use a bin size of 10. Okay. Now, when I build a frequency distribution table over here with bin size of 10, what will it look like? It will have the range and it will have the count or the frequency. That is the number of students. Let's say I have a register with me. The institute has given me the register or they've given me the list with the names of the students and their marks. So I'm going to check how many people secured marks in the range of 600 to 609. Why? Because rather than looking at the overall picture, I'm trying to do a deep dive into that data, right? I'm trying to do a deep dive and get more information about it. So I look at smaller intervals and I have used a bin size of 10, 600, 601, 602, so on up to 609. How many people? Let's say two people. Then I will inspect 610 to 619 and how many people? Let's say three. So on and so forth, I will build my table. And when I present the data in a graphical format, we will have range along the x-axis. We will have count along the y-axis. Let's say 5, 10, 15, and 20. 6, not 9, 6, 19, 6, 29, 39, 49, 59, 69, 79, 89, 99, 7. Okay, so two people got in this range, three people got in this range, five people, let's see, in this range, 10 people in this range. Let's say 20 people in this range, maybe only 8 in this range, maybe 6 in this range, maybe another 3 people in this range or 2 people in this range, maybe only 1% here. So the moment you create a histogram, it breaks the data into smaller ranges and it will give you the count in each range as a bar. This is a continuous range of bars. It's a histogram. And I can notice that the peak in the data is over here. Most of the people are getting scores in this range, maybe 640 to 649. Now let's say I created the same chart for Training Institute B. Okay, same range of 609, 619, 629, 39, 49, so on. And same 5, 10, 15, 20 count. Okay, let's say the chart looks like this. And this. Now, where will you go and join? Will you join in A or B? Obviously, you'll join in B because the peak in the data here is on the higher end. Many people are getting scores in the range of maybe 690 to 699. So something B is doing is working. The children or people are getting higher scores. Most of them are getting higher scores on the higher end, right? Here, medium, in the medium range. So we would want to join here. Getting it? So histogram is something that helps you break the data into smaller ranges, smaller intervals, and gives us much more clarity about the data. So whenever you see the word distribution, you could create a histogram, the simplest chart. Again, if your client is competent enough to understand box plots or violin plots or pair plots, you can create them. Okay, here, let's say I just want to perform simple analysis on the GMAT scores of a training institute. And I want to analyze it by creating a histogram. Okay, so I'll just select the field and create the histogram chart. So what do we understand from here? Most of the people are getting scores in which range? So when we edit the bin, we can see the bin size. Let's say I will use the bin size as 20. So I understand most of the people are getting high scores in the, most of the people, almost 240 people, slightly over 240, 243 people have secured marks in the range of 700 to 720. How many people got more than 780? Only two people. More than 780, only two people have got, right? So we can understand by creating a distribution chart, which is a histogram. Okay, so I'm not just showing you the charts. We are discussing when to create which chart. When should we create which chart? You have to take that call, make that decision based on the requirement, the question. Look for the keywords in the question. How do you choose the right chart type for any requirement? Look for the keywords in the requirement. Of course, talk to your client and understand their requirements really. And then once the requirements come to you, look for the keywords. If they're asking us to present the value, you go with a text table. If it's a question pertaining to comparison, go with the bar graph. If it's a question pertaining to showing the shares or proportions or part to whole analysis or composition, you hear these words, go with the pie chart. Trend, time series data, how are we doing over a period of time? You see such words, go with the line chart. What is the relationship between the variables? Can you perform prediction? You see such words, go with the scatter plot. What is the distribution of the data? You can go with any of the graphs here. Okay, there are some other charts also, like for example, Gantt chart. If you're asked to create a project plan kind of, let's say there are different stages in a project and you want to know when each phase has to begin, when each stage has to end. Okay, what is the duration of each task? Then you would go with a Gantt chart. If you're asked to detect outliers in the data, then you could create control charts and also box plots. Box plots come under two categories, distribution and also for outlier detection to detect the anomalies in the data. Okay, suppose you have to compare actual versus target. Then you could create dual axis charts. Now, we can't cover all the charts in the given time duration, but dual axis charts, bullet charts, gauge charts, okay, dual combo charts, all these KPI charts, all these can be created when you're comparing actual versus target. Then if you have data going through different stages in a process, like you take an interview cycle. Okay, first stage, how many people have taken the written test? How many people were eliminated? How many people moved on to the next round? Technical interview. Again, how many people attended it? How many people cleared it? How many of them were disqualified? How many moved to the next round? HR interview. Okay, so suppose you have such data. So I have written test. Not everybody cleared it. Some of them were disqualified. Rest of them came to technical interview, technical round. Of that, again, few of them reached the HR round. Of that, few of them were sent the offer letter. They were selected. So there is a gradual reduction happening in the data. It's going through a process of elimination, right? In such cases, we go and create funnel charts. Let's say I created a product. I'm selling a product on a website. So how many people came to my website? Of that, how many people have downloaded free trial? Free trial. Of that people who have downloaded the free trial, how many people contacted sales team expressing their interest in purchasing the product? Of the people who reached out to the sales team, how many people actually ended up purchasing the product? So in such cases, you create a funnel chart. When you have data going through different stages in a process and it experiences progressive reduction, we create funnel charts. Okay, so there are many charts in the world of data visualization. The ones that I've mentioned here and the ones that I've created and shown you today are the most frequently used charts. Okay. Rarely you might come across Violin or pair plots, but most often you will see histograms for distribution analysis. That way. Okay. So these are the most commonly used charts one needs to be familiar with, and also which chart to create when. That is the most important point in our agenda. Choosing the right visualization type, using colors, and making sure that you're following the rules and the principles of data visualization. I hope the session was informative. If you have any questions related to anything, please let me know. I will answer them. So I see one question has come where someone has asked, share the data you're using so that we too can do at the same time. Okay. See, the data is available on the internet. Superstore data is the most common data source. Just go to Google, open your internet browser and search for Superstore data source. Search for Superstore data source for Tableau. Just search Superstore data source for Tableau. And the very first link that appears, community.tableau.com. You can go to this link. This is Tableau community. Okay, you can go to this link. Just scroll down a little bit. You will find sample Superstore. This is the data source I have used today for most of the charts. Okay, you can download it from here. You can download it from here. All right, Gilbert, I hope that's clear. Vijender, you're saying allow us to access the data spreadsheet used in the previous playlist, data using MS Excel, data analytics with MS Excel. Vijender, you have, I think it's already provided. Recently, we have updated the data source. There's one Excel workbook with all the data sources present there. Just check out in the videos. Mostly in the first video itself, you should find it. If you're not able to access it, please reply to that link, the message with the link, and the team will provide you with the access. Okay. Amit, yeah, I understand. Initially, I think the voice was breaking a little, but I hope it's clear. The initial 5 minutes, it was a little problematic, but I hope later on it's clear. Do you offer certificate? Not for this webinar that you have attended now. No, but we do offer trainings on different courses at 360 Digit MGs. Please do visit our website. Please do visit our website. You can explore the different courses that are available. Okay, under data science, data analytics, MLOps, analytics specialization, lot of things are there. Digital transformation, ML on cloud. So you can check out if there's any course that you're interested in learning. You can reach out to our executive. You can apply for it. You can also reach out to our executives. You can call us. You can message us on WhatsApp. You could write to us, info@360digitmg.com. Okay, and of course, now that there's the festival season going on, we have a very big festival, Diwali, coming up, right? So there will be some special discounts also. So whoever is interested in further learning about data analytics, data visualization, or data science, or any of these courses offered, please do get in touch with the team. You can call us or message us or drop an email, make an inquiry, and we will get back to you with all the necessary details. Okay. And I would say don't miss out on the offers that are available right now because of the festival season that's going on. Um, you can make the best of it. And yeah, if there's anyone who has not subscribed to our YouTube channel, I would greatly appreciate if you could subscribe. We will keep putting very good content from time to time. You can make the benefit. You will get the benefit if you kindly subscribe. Okay. And for every lesson, every topic, every module, we have mind maps. Okay, very interesting. Check out the mind maps also. Just search for mind maps. You will find it here. Every topic, it will be like a quick revision. Even if you have to go to attend an interview, last minute, you could just open the mind maps and very quickly revise all the important topics and concepts. Okay, so please do check out the mind maps as well. So that's it from my side. Thank you all. I hope I have answered all of your questions. Yeah. Thank you. All the best. Bye bye.